Well, this is about power consumption testing. This is one of the topics widely discussed and which is most crucial part in mobile testing, which I believe if your application starts sucking the battery and it'll be easily uh, identified by any user and they will really uninstall your app just like that because and is it that real that a mobile application can suck power? Yes, indeed it will. For example, if your mobile application has a loop which is not closed and it's keep consuming the CPU when it's running in background mode, and CPU obviously eats battery, and that is how it goes. And so power consumption testing is really important. It's required before delivering your app to the market. And as you are already aware that you have a power consumption, you have different chips that consume different power in your mobile phone, and there is a power management chip that handles it. For example, Wi-Fi chip takes 12 volts and Bluetooth chip takes 5 volt. Power manager will supply different power, and it is in real life also. If you are not using the Wi-Fi, you should switch it off, and if you're not using the Bluetooth, you should switch it off so that you will be able to save some power. At least 30 minutes of power you will be able to save if you're keeping your Wi-Fi and Bluetooth turned off when you are not using it. So the three methods I really wanted to discuss at this point in time. The old method, which we've been using like 5-6 years ago, because there only feature phones were available and there is no way I can find out how much power it has been consuming. Now there are apps, there are platforms like Android can even display how much power it's been taken. So the old method was we used to fully charge the mobiles. For example, we are actually testing in a OEM environment and it's an SMS application, or we are going to power consumption test, and we fully charge the application, fully charge the mobile, sorry, and we take another competitor mobile and we will fully charge and make sure that we are taking the same power of battery for example, if you check GSM Arena, the battery, normally they display the size of the battery. Let me just take a look, and maybe we'll take this mobile. Take a mobile. Let's read the full phone spec. This is a full phone spec. Look at this. 1430 milliampere of battery, and in this scenario they will tell you 336 hours standby and up to 336 hours in 3G 2G, but it may not be really true, and because in 2G it consumes less battery than a 3G. 3G sucks very quickly, but this is a total battery, and normally in the old feature phones we used to open the back cover and then take the battery out and check. It will be written there. You can check it if you have a feature phone. And now batteries are actually inbuilt, so you will not be able to check, but you can check that in the specifications like this. And so with this we used to take a competitor mobile of same power, and we create an Excel sheet kind of thing, and with basic features we fully charge the mobile 100% and perform different scenarios. We start the timer, perform that scenario, and then we will note down each battery bar, how much it is. Maybe I should really create that sheet for you at this point in time. Like, let me just create a sheet. So test DUT, competitor DUT, okay, scenario. So scenario is open SMS application and send 2 SMS messages. So at this point in time, battery bars, like 5 bars, and wait for 10 minutes, 5 bars. Say start time 10 a.m. and then we open media player. This will test the whole mobile phone and play a video. 5 bars. Wait, or I would say stay idle for 30 minutes. 5 bars. Open browser and browse web pages up to 10 minutes. 5 bars. It takes time, and when you're doing power consumption testing, it takes time. A lot of patience is required. Stay idle for 1 hour. 5 bars, and receive an MT call, mobile terminated call. 4 bars, MT call, and speak for 10 minutes. You cannot really speak for 10 minutes. So we used to play music both the sides, and then we used to listen that so that the traffic channel will not get blocked. That is how it goes. It is 5 bars, for example. So we continue the test. End time 6 p.m. So after full test, so you are actually testing for 8 hours now. 4 bars or 3 bars. Assume that we have a lot of scenarios written in the middle, and then you will keep the phone idle. Keep the phone idle and leave. The next day, starting the test with sending 2 SMS, 2 bars, 3 bars. This is how it goes. So you can count the entire. So the moment battery is dead, 0 bars and dead, it will happen. That time, if competitor phone is having still 1 bar, then the same battery milliampere, like for 1430 milliampere, your phone consumes more battery than a competitor. That is how you will end up in that kind of scenario. So constantly you will really improve the power consumption, because it's if you are displaying that 330 hours of idle time, then you should really make sure that this 330 hours is being elapsed when you are actually idle. So this kind of tests used to happen, and this is our old method. And new method is start the timer before that, charge the mobile 100%. Perform different scenarios. Check the settings for battery percentage in each mobile phone, because in the new phone like an Android, there is always settings and it started displaying it how much batteries exist. You can note that down. For example, 80%, 90%, or 99%, 80%, 50%, like that. You can note that down, percentage of battery remaining. This is a new method where the application mobile started displaying the battery percentage. There also you can create that kind of sheet and perform the scenario. If your application is specific to one app, these scenarios will be specific to one app. If your application is testing app, or say British Airways app, open BT Air app and create account. Wait for 10 minutes. Open BT app and check dashboard. Stay idle for 30 minutes. Open BT app and immediately push it to background. Stay idle for 1 hour and then open BT app and sign out. Keep the phone idle for another hour, like that. This is how you will test an app in the scenario of testing an app itself. So in this scenario, instead of this comparison, you will compare with different builds. Build version number 1, build number 2. Based on that, you will compare your both app. Instead of test DUT, competitor DUT, build 1, build 2. This is how you will test a single app of power consumption, single app's power consumption. This is how it goes. And in your screen, your LED screen, LCD screen, that itself consumes a lot of power. I actually checked Samsung S2, which consumes up to 500 milliampere of power when it's open. And for example, if it is a 2000 milliampere battery, 4 hours I keep the screen completely open and doing things, and 4 hours the charge will go almost zero. So that is how it goes. Foolproof method. The third method which I'm planning to tell you is use Agilent 8960 or an Enrich2 to set up a data acquisition unit dummy battery power supply. It's actually very costly setup where you have a signaling tester like Agilent 8960. Look like this. And it is, for example, it is connected to a phone and GBIB cable, and you can keep a data acquisition unit in the middle. It will look like this, and then in a millisecond how much battery is being consumed, it can be verified using that, which is foolproof, that you will exactly get how many milliseconds has been consumed in a particular scenario. But this is very costly device, up to $1 million, which small companies, making companies may not really be able to afford. So that is how this is. There are tools like PowerTutor, GSAM, Battery Life Pro, Easy Battery Life. You can check the battery of the particular app, and also an application called Little Eye, which I've been using it. I think Google, but Facebook purchased it very recently. It's an Indian company that it will give you the complete performance of an app. It's an amazing tool that I have access to it because I'm an user of this tool. So if you are testing an Android app, you should really download this tool and try it out. It is an so amazing tool that it will give you complete analysis report of a power consumption. So objective of this is to give you an way to start testing your application's battery as well in the testing environment, which is the core of a good product. So I gave you that at this point in time. I'm sure you will try out these different tools and from the market and Little Eye, and also these methods being discussed here in your testing environment, and make sure that you also strategize your power consumption testing. And I thank you very much for watching this, and I'll see you in another session. Thank you.